All right, in this first lesson, we're going to talk a little bit about encoding text. And prior to watching any of this, please read Chapter 8. Schneider does a great job of going over a variety of different concepts here on how to encode. He talks a little bit about encoding audio, encoding video, encoding colors, encoding text. I'm just going to talk about encoding text here. All right, but let's put this in context a little bit. We all got our little handheld communication devices, our cell phones or smartphones or whatever you might be carrying around in your pocket. And one of the very simple things that we do on a regular basis is we text message people. In that text message, what actually happens is that we encode text, and then we send it across the airways, all right? And then on the other end, our recipient, their little machine that they have in their pocket decodes it. All right, and so how does all that process work? Well, of course, they use computers to do that. And what happens is when I put in that text, it converts all my letters to a series of ones and zeros, because that's the way computers store information. You might want to think of, and it's binary, of course, but you might want to think of like a light bulb, because that's about all computers can do. Light bulb's on or it's off. If it's on, it's a 1. If it's off, it's a 0. And this is the type of, so if we have a whole bunch of light bulbs, say you have 8 light bulbs, you turn them in the right combination, turn them on and off the right combination, you can store any letter in the alphabet and then a whole bunch of other extended characters. All right, and that's kind of what we're going to look at here. Let me go back to an older technology here. Let me bring this into context because this isn't a new idea. And I'm pulling up right here on the screen here. You'll see something known as the Morse Code. So in the old days, and perhaps maybe the very first form of electronic communication, we had something called the telegraph. And on a telegraph, you had an operator on either end, and one operator would key in the text, and he'd use that with a series of long and short signals. All right. So for instance, to send a B across the line, he'd have one long signal followed by 3 shorts. And then the telegraph operator on the other end would interpret that and write it down. And that's the way messages were transported using this very simple device known as the telegraph. All right. And Morse code was the agreed upon standard. So everybody sat down and said, all right, we got to get use the same series of longs and shorts across this communication medium. And so they agreed upon a Morse code. And thus that was the telegraph. All right. Let's fast forward here to the 20th century when we came up with a tool called the Ascii Table. All right. Kind of same process. Everybody sat down and came up with a standard, and we'll just keep finding throughout the history of computers, standards are huge. Standards make all of us able to talk and communicate and pass information back and forth. All right, so here was the Ascii Standard. Not so much important, how it came about, but the fact is that everybody uses this. Your little device that sends messages across airways has an Ascii table that it's used to encode information, transport across the line, and on the other end somebody's able to decode it. All right. So for instance, the letter, well, we have capital and lowercase. So remember the significance of that. Those are different letters. And if we wanted to get a uppercase A encoded using ASCII code, we'd encode it as a 65. All right. Or the equivalent of 65 as a binary number is 01000001. All right, now that's pretty hard for us humans to read, but it makes perfect sense to computers because that's the way they think of information. Remember the analogy I used, 8 light bulbs? Well, here's 8 light bulbs across here, and this light bulb's turned on, and then the very last light bulb's turned on, and that's how we represent a capital A. Same would be true for lowercase a, except for lowercase a would be 97, and we turn different light bulbs on and off. All right, so it's I'll leave links to these in your learning management system. But here's another, and again, it's the same thing as we had on the last page, but this one's set up a little differently, and this one actually shows you decimal numbers, hexadecimal numbers, octets, okay, which we're really not going to cover here, and then we can also, and this is very interesting now, we all know a little bit about encoding using HTML, we can actually represent letters using the ASCII character set in HTML if we start with an ampersand, a pound, and then the equivalent decimal ASCII number for it. All right, so if we wanted to put in a capital A, decimal number of that for the ASCII table is 65, and we could put ampersand pound 65, and that's capital A. Note capital A 65 here. It's the same ASCII table that's shared throughout the world. All right, let's try and do a little example now. So I'm going to pull up Notepad here, and let's encode something really complicated, right? We're going to encode the word dog. All right, so we'll start right here, and we're going to code it using decimal numbers. So dog, D, capital D, is 68. And then let's go find lowercase. This works out nicely because I think I could share the screen here. So let's go find lowercase o, which is over here, and that's 111. And then lowercase g, okay, and that's going to be 103. All right, so we've taken the word dog and we've converted it to numbers, and this is actually using the ASCII table. And we could go ahead and take 68 and write it as a binary number, or 111, or 103. We could do any of those. Okay, so let's try one more example here so we know how to read this table. So if we look at hexadecimal numbers now, let's try and encode dog using hexadecimal numbers. We go find our capital D, all right, and that's actually going to be the number 44. All right, and then our O and our G. Here's our O, it's 6F. Boy, that looks unusual. We'll hang in there. We'll look at how to count using the hexadecimal number system in a later video here. All right, and then the last one I want to pull up here is a lowercase g, and that's 67. All right. Now, why are we bringing up the hexadecimal number and the whole system? Well, one of the advantages with the ASCII table is that any character can be represented in hexadecimal form using only 2 characters or 2 digits. All right, and then the other thing that we find is that hexadecimal, because it's base 16, converts very easily with binary.